you guys how to test hypothesis on a matched pair data. I choose a question from the book on page 490. It's question number 11. It says, to test the belief that the sons are taller than their fathers, a student randomly selects 13 fathers who have adult male children. She records the heights of both fathers and sons in inches of this data right here. And then the question is asking, are sons are taller than their fathers by using the alpha equals to 0.1 level of significance. Right here is the data, and then we're going to put the father's height as x in L1, and then we're going to put the height of sons in L2, okay? And then since we're dealing with the differences, we're going to use L3 to find the difference between L1 and L2. So we can highlight L3, and then we're going to do L1 minus L2. So this should give you the difference between L1 and L2, okay? And then to begin solve the problem, we have to make sure some criteria. We have to make sure that the data, the sample data are randomly selected. So we can check right here, it says randomly selected for 13 fathers. And then we also need to make sure that the data actually are matched pairs. So we can see is father and son, the question is dealing with the fathers and sons. So we are dealing with the matched pair data. For the third criteria we have to check is to make sure the data is randomly distributed. So we can see notes right here. It says normally probability plot, and the box plot of data indicates that the difference are approximately equal, normally distributed with no outliers. And also, lastly, we have to make sure that the sample is actually less than 5% of the whole population. So we can see the sample size is 13, and then that is definitely smaller than the whole population of the 5% of whole population. After we check all the criteria, we can move on to solve the problem by classical approach. To do that, we're gonna state the null hypotenuse is equal to 0, and then the alternative hypotenuse is less than 0, because when we are subtracting the son's height from the father's height, we should have a negative number because we are testing the sons are actually taller than their fathers, okay? So when we do that, we can start our test by finding the t-value by the calculator function called t-test. And here's the steps you can find. You can find the t-test in your calculator. After that, we can see the t-value is negative 0.3925. Okay, so once we have that, we're going to check if this number falls in the critical area. So to make sure that, we can use the calculator function called inverse t. Here's the way to find the inverse t in your calculator, okay? And then we're going to use inverse t, which is, we're going to say the level of significance, 0.1 right here, and then the degree of freedom, which is n minus 1, so it's 12. And then we can see the answer is negative 1.3562. So we're going to draw a graph. We can see it's a left tail. We're going to do right here. And then this area is 0.1, is the level of significance. And then the number right here is negative 1.3562. And then we can see that the t-value we found is negative 0.3925 is not fall in this critical area. So we're going to say do not reject the null, okay? And then after we finish this, we're going to move to the p-value approach. We're going to use the same function called t-test right here with this. But instead of looking for t-value this time, we're going to actually looking for the p-value underneath the t-value. So it's this. And then for the p-value approach, it says if the p-value less than the alpha level, we're going to reject the null. But since for this question, the p-value is actually greater than the alpha level, so we should say do not reject the null. There are also a third method to test the hypothesis of the matched pair. It's called the confidence interval approach. But since we are not dealing with a two-tailed test, so we cannot use the confidence approach, confidence interval approach for this one. And the end, we're going to do a conclusion. We're going to say there is not sufficient evidence at the alpha level of equal to 0.1 significant to conclude that the sons are taller than the fathers.